COMSOL Multiphysics Lecture 1, the structure of CAE analysis. First of all, you open a COMSOL procedure, and at the same time you open a CAE system, for example SolidWorks. And in the CAE system, you open a part file, and for example on XY plane, enter sketch mode and draw a rectangle and extrude it into a brick or a block and save it. Save the file, for example, on desktop. And before you actually run the procedure, make sure that the software is loaded. So in Tool, Add In, or Fast Drop-Down Menu, Add In, you have to check whether the software is loaded. For example, the checkbox on the left will be loading COMSOL this time, and checkbox on the right will be loading COMSOL whenever you open the CAE system, for example SolidWorks. So now we have loaded the software. Now we need to link the two softwares. There's a tool on COMSOL, the live link for COMSOL, and this procedure provides a function to connect or link between COMSOL and CAE system. And this is first mode for COMSOL analysis. But I'm going to talk about the second mode to run COMSOL inside a CAE system. For example, I can load the software and then load the toolbar. And this is the COMSOL toolbar. And if I click on the New Model tab, I will open the COMSOL, and the COMSOL procedure will dock in or merge inside SolidWorks environment. So this is the second mode, docked mode. The CAE software is open inside SolidWorks environment or any CAD environment, and it is more convenient working with CAD and CAE at the same time. So this function is available only after version of 5.2. If you have version 5.1 or earlier, you can only choose live link option. So we can choose physics here, solid mechanics, or if you use solid mechanics before, you can choose it here in recently used modules, and you add it into the procedure. If you forget to do this and click on done, it's okay, you can do it later, but we better do it here. So we have chosen solid mechanics, and within solid mechanics there are statics, dynamics, model analysis, or free vibration, or eigen frequency, or even buckling. For the present time, we choose stationary, which is statics analysis. And I will enter actually SolidWorks environment with COMSOL docked in or merged inside SolidWorks. And this is the COMSOL model tree. The first step, geometry. Second step, material. Third step, meshing. Fourth step, boundary conditions and loading. Boundary condition and loading. And implementing computation or running the procedure and the result. So it is 1, 2, 4, 3, 5, 6. So in SolidWorks simulation, it is 1, 2, 3, 4, 5, 6 Cosmos, right? In ANSYS, it would be 2, 1, 4, 2, 1, 3, 4, 5, 6. And in COMSOL, it is 1, 2, 4, 3, 5, 6. So whatever the CAE software, it is only the difference in the order of these 6 phases in the structure of CAE analysis. So we have finished with the first step, which is drawing of a 3D model and opening a case or a procedure. And for the second step, material, right-click the mouse and choose material library entity or a blank material. For now, I'll choose an entity from material library, a building material called structural steel, and I'll add it to the selection. And make sure that the geometry is connected to material properties. It is very important that you define the material properties and connect it with the geometry. In COMSOL, you don't have a confirmation step, so if you accidentally click on the other places, the connection is disappeared. So make sure that you implement the connection. And I also suggest that there is a confirmation step in the choices, because for example in all the other softwares you have confirmation steps, so the user won't make mistakes by accident. So now make sure that the connection is okay and the geometry is connected to the material properties. And the third step will be meshing. You can mesh it finer mesh or coarser mesh. I'll make a finer mesh and build a mesh using this geometry. So I finished with the third step. For the fourth step, it will be boundary conditions and loading. Right-click the mouse and choose constraint. And I will fix this surface. Again, there is no confirmation step, so you have to be very careful about this. And for the loading, you choose boundary loading and choose the upper surface. And in COMSOL, there are 4 steps in defining a load: the type of the load, concentrated load, or distributed load, or force divided by area. So we choose concentrated load, total force, the type of force, the area on which the load is applied, the surface of the load, the direction of the load will be y direction, and the magnitude will be minus 100 or 100 Newton in the negative direction of y direction. So in COMSOL, the loading has 4 parts to define: the type of load, the surface of the load, the direction of load, and the magnitude of the load. So up to now, we have finished with the 4 steps of CAE analysis: the geometry, the material, the mesh, and the boundary condition and loading. And by this time, we have completely defined the problem, and these are called the preprocessors of the problem. And now we can go ahead and implement the computation for the procedure. And COMSOL gives a stress result, and we have to define our own plot. For example, for displacements, for this is a stress plot. If you want to plot a displacement, you have to do it. For example, you can right-click the mouse, choose 3D plotting group, and this is the 3D plotting group. It is an empty case, so you have to define surface plot. And in surface plot, you need to choose the items that you will plot. For example, in this case, we plot displacement, and you can also change the expression into other entities like stress, strain, or even displacement. You can choose XYZ component of the displacement. But for now, we will use the default, the total displacement, and we'll plot the displacement plot. And also, if you want to plot it in a deformed way, you need to right-click the mouse and choose deformation, and you get a deformed shape of the geometry. And now there's also other functions available. For example, you probe the data values. You can probe the point evaluation and choose, for example, this point and this point, and evaluate the number here. This is the numerical value for the displacement of this block right here. And you can also derive the, for example, average value of the surface. For example, the displacement of this surface, the average displacement of this surface, evaluate. So you can evaluate even the integration of the surface. The numerical value will get you calculation result. So, but for the animation, it is quite complex. You can generate animation, but I'm not going to talk about it right now. So in this lecture, the most important thing is that you can choose from the two modes that you'll run COMSOL with CAD systems. The first one is the live link mode, and the second, the live link mode, linking the geometry with the procedure between two softwares. And the second is to use the docked mode. For example, in this example, you use docked mode, or you merge the COMSOL software inside SolidWorks. And this is a more convenient way of doing a COMSOL inside a CAD system. And this function is available only on version 5.2 or later. And this lecture is very important because you must familiar with the 6 parts of the structure of CAE analysis. The first part is the geometry, the second is the material, and the third is meshing, and the fourth with boundary condition and loading, and the fifth step will be running the procedure, and you get the sixth step, which is the result. And this is a structure that applicable or applies to any CAE softwares, including ANSYS, COMSOL, or Nastran, or Cosmos, or SolidWorks simulation. So for anyone new to this field of CAE analysis, you must be able to memorize or be comfortable with these 6 steps of CAE analysis, so we can run the software more smoothly.